Haloalkanes are organic compounds that have a hydrocarbon base with a halogen as their functional group. So they have a general formula RX, where R is an alkyl group, like methyl or ethyl, propyl. So it could have 1, 2, 3, any number of carbons in it. And X is the halogen. And the halogen could be fluorine, chlorine, bromine, iodine. Haloalkanes are formed by substitution reactions of alkanes or addition reactions of alkenes and alkynes, as we've already learnt about in the alkanes and alkenes sections of this topic. So how do we name haloalkanes? It's quite similar to naming alkanes. We work out the name of the parent chain, but in front of that we put the prefix for whatever halogen or halogens are present in the compound. So the prefixes for fluorine is fluoro, chlorine becomes chloro, bromine becomes bromo, and iodine becomes iodo. If there's more than one in the list, you put them in alphabetical order and they go right at the very front of the name. Then we need to number our parent chain, as we often do, giving the positions of the halogens. Now the halogens need to have the lowest number possible if they're the only functional group in the structure. Numbers giving the number of the halogens can be indicated as well. So if you have more than one halogen, you need to use di in front of the prefix for the halogen, or tri for 3, tetra for 4, and so on. So if we have a look at this example with 3 carbons in the parent chain, we number from right to left in the carbon chain to give the chlorine atom the lowest number possible. So this becomes 1-chloropropane. That's what we call it. In the second example here, we've got 2 bromine atoms attached. To give them the lowest number possible, we start numbering from the left in the parent chain, which is 4 carbons long, so it's going to be a bromobutane, but there are 2, so we use the prefix tri, and we have to say where those bromines are. So this structure is named 1,2-dibromobutane. Then we can classify halogens according to where the halogen atom is bonded in the molecule. Isomers of haloalkanes can give us primary, secondary or tertiary versions of the haloalkanes, just like we get primary, secondary and tertiary alcohols and amines as well. Now when we look at this, we look at where the amine group is bonded. We look at the carbon that each of the chlorines in these situations are bonded to. Now in the primary, you see the carbon that the chlorine is bonded to has 2 hydrogens directly attached to it. So if it has 2 or 3 hydrogens directly attached to that carbon, then it's going to be a primary haloalkane. When that carbon bonded to the chlorine atom has only 1 hydrogen attached, then it's a secondary haloalkane. And if that carbon has no hydrogens directly bonded to it, then it's a tertiary haloalkane. So classification depends on whether the carbon atom to which the halogen group is attached is bonded to 2 or 3 hydrogen atoms, making it primary, 1 hydrogen atom, making it secondary, or no hydrogen atoms, making it tertiary. So let's have a look at a couple of examples. We should pause the video here, and name these haloalkanes and classify them as primary, secondary or tertiary. When you're ready, restart the video and check out the answers. So for the first structure, we've got 2-chloropropane. That carbon is bonded to just 1 hydrogen directly, so it's a secondary haloalkane. The structure here is 1-fluoropropane, and it's primary. 1-iodoethane, primary. 2-bromomethylpropane, and it's tertiary because the carbon with the halogen attached is bonded to no hydrogen atoms. That's how we identify it. 2-chloro-3-methylbutane is secondary, and notice the chlorine group gets a lower number than the methyl side chain. Functional group gets the lowest number. And the last one, fluoromethane, which is primary. Have a go at matching up these structures with their names. You can pause the video to do so and come back and check out the answers. Is this the result that you got?